Hello, I'm John Klobuchar with InEight, and I'd like to welcome you to the latest webcast in our Planning, Scheduling, and Risk series. Today's webcast is titled, Why You Need an AWP-Based Path of Construction. Our presenter today is Dr. Dan Patterson, who is InEight's Chief Design Officer. In his role, Dan focuses on expanding upon his vision of creating next-generation planning and scheduling software solutions for the construction industry. Dan is a certified project management professional by the Project Management Institute. If you have any questions as you watch the webcast, please email them to webcasts@innate.com, and Dan will do his best to answer them. Also, this presentation is being recorded, and we'll be sending you a link to the video in about a week's time. Once again, we're glad you've joined us, and now let me introduce Dr. Dan Patterson.
Well, thank you, John. So I'd like to spend the next few minutes sharing with you my thoughts and, more importantly, my excitement about the emerging science, more commonly known as AWP or Advanced Work Packaging, and specifically talking about this entity called the path of construction. Now, before we get into the details of AWP, I think it's probably useful just to set the scene and look back at how major CapEx projects to date have been planning and executing during the project phase. So traditional planning philosophy has really always been about planning from left to right. We start by defining a project start milestone. We then define our engineering scope. We then sit down and look at the procurement and fabrication work and deliverables that are required. Those deliverables then get fabricated, delivered to site. They then get installed or constructed during the execution phase of the project. And then we move into commissioning and closeout. So, very much a left to right mentality. And again, I think historically, we focused on what we call the critical path, the work elements that don't have any float, such that for every day that they are late, they have literally a one-for-one knock-on effect per day on the project completion date. Now, while I think that is certainly a sound means of planning, one of the massive downfalls is the fact that on that critical path, moving from left to right, if we have delay starting in the very early phases of the project, again, let's take our engineering scope, again, we have a one-for-one delay knock-on effect. So, I think, yes, planning from left to right is effective, but the project then becomes very prone to compounding delays along that critical path. And so the net of that is that our project completion milestone becomes highly uncertain. I think because of that, again, traditional planning has really generated what I call the best case scenario versus the most likely scenario. So with that, when we start to look at this emerging planning technique known as AWP, I think probably the biggest mindset change is the fact that, first of all, we're planning from right to left. We don't start with a defined start date. We actually start with a defined completion date. And then from that defined completion date, we literally work backwards, defining the construction or the execution scope. Then we look at, well, what and when is needed in terms of fabrication in order to satisfy that construction. And then taking that a step further, what is needed and when is it needed from an engineering perspective in order to feed into that procurement, which then feeds into construction. Now, this concept of what we call the path of construction, it's really all about the sequence of steps for execution. Now, that's very different to focusing, as we have historically, on the critical path. There may be mission critical steps during the startup sequence that are not necessarily on the critical path, but are absolutely needed in order to execute that startup sequence. And really, that is the thinking behind defining what we call the path of construction. Now, a lot of literature pertaining to AWP talks about getting the right people with the right materials at the right point in time to the right location. So a lot of the value and benefit of AWP is really around alignment. For me, the benefit of alignment of those entities together with planning from right to left to ensure constraint-free execution is really driving forecasting certainty or our ability to forecast more accurately. Again, I think this is then resulting in the cost estimate, the schedule forecast, really being more of a most likely scenario rather than a best case scenario. So there's been a lot of publicity around the benefits of AWP, and some of the metrics that I think are very interesting, 10% cost improvement and up to 25% productivity improvement. Who would not take that seriously with regards to a CapEx investment? So there are multiple definitions of AWP or advanced work packaging. The Construction Industry Institute, or CII, has what I would suggest is a little bit of a wordy definition. It talks about the overall process flow of all of the detailed work packages and installation work packages. It talks about AWP being a planned and executable process that encompasses the work on a project. It provides the framework for productive and progressive construction and presumes the existence of a construction. Now, that's all very well. I think that really just boils down to, look, at the end of the day, we are planning with the end in mind. We are starting with the end goal. We are focusing on construction and we are working backwards. I think another very interesting definition is thinking of AWP as an integrated and iterative planning and control approach for ensuring constraint-free, as per planned, predictable project execution. Again, if we can ultimately execute as per plan, then that's really the holy grail of project management. It's when we execute outside of that plan that we have the perception that the project is incurring overruns with regards to cost and schedule. I think another interesting point to note is that AWP is the culmination of both front-end planning and work phase planning. Traditional project management has been highly sequential. We start with the planning phase, and then we throw that over the fence and we get into execution. Well, with AWP, we're really planning throughout the entire project lifecycle. We're doing our front-end planning, but then I think more importantly, we are continuing to plan in the field with work phase planning, and that front-end planning, or FEP, is perfectly aligned with our field execution planning. So obviously AWP pertains to both owner organizations and contractor organizations. I think there are mutual benefits for both of those parties. The fact that we are absolutely reducing the CapEx duration and CapEx cost, I think is a massive benefit. Part of the reason why we're able to achieve that is an increase in productivity. But I think ultimately the number one benefit of AWP is a project's ability to more accurately predict the project outcome. It's in some ways it's irrelevant as to what the project duration and the project cost is if we don't have an associated confidence level against those forecasts. Project alignment, I think, again, looking at the benefits of AWP, I think, aligning the age-old triple constraint of time, money, and quality is a huge benefit. I think historically, when using traditional, for example, CPM planning, you can certainly focus on an optimized duration or schedule, but typically that's at the expense of project cost and arguably quality. With AWP, we are aligning all three of those variables. The fact that we are also aligning the outcome prediction. So think of the outcome prediction, it's the plan, and aligning that plan with outcome reality, which is execution. The fact that for the first time, engineering, procurement, and construction are aligned such that the engineering scope feeds in a timely manner the procurement scope, which feeds in a timely manner into construction, I think is a huge deal. And again, this concept of aligning materials, people, tools, and location, it's really a different way of thinking about the work that needs to be executed. So let's spend a few minutes now looking at the workflow behind AWP. So think of AWP as a two-dimensional framework. And again, not to harp on about this, but we are planning from right to left. We're starting with a target completion and looking backwards as to the supporting elements that are needed to support that on-time construction. Secondly, on the vertical axis, we are breaking out our project scope, starting with an overall project definition and a target completion, breaking that out into 5 levels of detail, 3 of which, as you can see on the diagram here, pertain to what we call front-end planning, and then level 4 and 5 pertain to what we call work phase planning. And again, I think this is such a massive step forward in the science of project management, because for the first time, the concept of planning in a planning office prior to execution and then marrying that up with field execution and generating daily plans, for example, by perhaps a superintendent or a foreman. For the first time, that big picture CapEx plan is in alignment and also is being updated by the execution reality out in the field. So level 1, we define what we call our path of construction. And the example on the screen here shows an oil and gas project where we have 2 forms or 2 sources of scope. We have an onshore refinery and an offshore scope of work as well. In order for the overall plant to operate, both onshore and offshore scope have to be completed. So our onshore commissioning has to be completed, our offshore hookup campaign. Both of those then feed into our offshore startup, which then drives onshore startup. So they are very high-level entity deliverables. And again, it's interesting that the onshore commissioning scope isn't necessarily on the critical path with regards to float, but it is absolutely required in order to achieve project completion and onshore startup. Going down to level 2, this is where we start to really chunk or break out the scope of work into different work areas. So these are geographical areas. These could be different trains within a process plant. They could be east, west, different blocks on a linear road build, for example. Then we get into level 3, which is really more akin to activities within a traditional CPM schedule. And again, the key here is that we work backwards. We first of all define our construction work packages. Then we look at the corresponding procurement and engineering work packages that are required to satisfy those CWPs. And typically those CWPs at a level 3 in a construction schedule are really no longer than 40,000 man-hours. So at that level, we have completed our front-end planning. Now, at that point, when we get into actual execution, that's when we take those CWPs and break them out into what we call installation work packages. They are much smaller elements of work, typically no greater than 1,000 man-hours. And again, taking that literally down to the daily plan or the short interval planning level, we then get into crew-based planning down at level 5. So let's take a look at each of those 5 levels in a little bit more detail. So the path of construction, think of this as your project goal. This is, as we mentioned, it's the logical sequence of events in order to support startup of the project leading through to project completion. And again, it's so important to understand this isn't simply just the critical path. There may be path of construction elements that are non-critical from a duration driving perspective and a float perspective, but they are absolutely needed in order to achieve project completion. So typically, path of construction elements are defined in a CPM schedule at level 1, so really the highest level. And what I would suggest is think of your path of construction as it's your baseline. It's the thing you are marching to as you detail out your project. Now, one of the very groundbreaking and I think exciting initiatives that we're undertaking at InEight is the fact that we recognize that this level 1 path of construction, it is essentially the milestone view of your overall project. Well, we are leveraging artificial intelligence and machine learning such that as you define your path of construction, being able to leverage and interrogate prior projects and look at prior as-built schedules and say, okay, well, in these previous analogous projects, these were the milestones that were achieved. This was the sequence of those level 1 elements. having the planning software augment and guide us through the definition of this path of construction, I think is a massive leap forward. So think of the creation or the definition of the path of construction as you're first of all defining your overall project goal. Now, secondly, it's all very well to have these perhaps, dozen high-level path of construction elements, but as we get into more detail, we need to break those out into manageable areas. So that's where what we call the CWAs, or the construction work areas, come into play. So typically a construction work area is a geographical subsection of the overall project. And I think what's key or important to note here is we're not just slicing our path of construction into multiple CWAs, we're decorating and enriching that path of construction with other entities. So whether you're using a 3D model or a 2D plan or plot, being able to associate those 3D models and the subsections with those CWAs is very, very important. Again, from the CWA level, we'll get into the details here, but we will then define corresponding engineering and procurement work packages. And so at this point, you're starting to hang things like equipment lists and material lists and your CPM subnets against these different CWA elements. So think of the CWAs almost as sub-projects that hang underneath the overarching path of construction. So CWAs help us manage across multiple disciplines, manage subsections of the project. So the third level is then the construction work packages. And in many ways, this is really where the rubber meets the road, because this is really us looking at defining instruction of work. So level 3, typically not planning to anything greater than 40,000 man hours. This is where we are defining work activities. These are the activities that are discipline specific, and these activities absolutely carry CPM sequential logic. They carry man hours. They also carry those drawings and those sub-elements from the 3D model that we saw in the previous slide. So at this level, we have durations, we have costs, we have 3D entities, we have the people required, we have the man hours, we have the materials that are required. So really what we're doing now is we're starting to define a list of what we call a list of constraints, all of the elements that are required to execute this instruction of work. And I think what is so brilliant about AWP is if we can define these elements that are required for on-time execution, as we are doing here as we detail out our goal, that list actually becomes this constraint register. In other words, let's not actually start execution if indeed some of those constraints are present. So this concept of not just defining the construction work, but actually listing the associated elements that enable the execution of that work, flip that on its head, call that a constraint register and manage that constraint register. Again, that's such a different way of planning relative to traditional CPM planning and scheduling. I think another interesting point to note about the definition of CWPs is there is a thinking that says, look, don't bother defining your CWPs until we are no more than 90 days out from actually executing the work. And I think the reason behind that is understandably sequence may change, even scope may change. That constraint register may not yet be completely mitigated. There's very little point in defining this level of plan detail until we are a relatively short period away from the actual execution. I think, again, some of the magic that AWP brings to the table is then the concept of once we've got these CWPs, then let's use our path of construction as almost like a bucket. We want to make sure that our CWPs adhere to those bigger picture bucket path of construction elements. So again, constantly using that path of construction as a framework, as a target. And again, that framework is all driven from right to left. So once we've developed our construction work packages, we then take a step back and we look at the elements that are needed to support the need date or the on time or the timely start of construction. So what we mean by that is once we've defined the construction scope, let's now move to the left and look at the fabrication elements and the supporting procurement elements. What is needed to be procured, by when, and where should it be delivered in order to support the need dates of that construction scope. So what we're doing here is, if you remember at the beginning when we talked about traditional planning and this concept of the compounding effect of delay going from left to right, what we're in effect doing here is de-risking that compounding sequence risk exposure and starting from the right and saying, okay, let's build in sufficient float into procurement. And then taking that a step further, let's build in sufficient float from an engineering perspective such that the chance of that compounding delay ever happening is as low as possible. Now, again, one of the very exciting, innovative initiatives that we're working on at InEight is the concept of artificial intelligence support for rules of thumb. So rules of thumb, again, they're supporting the insight, looking at the construction scope and saying, okay, well, in order for this construction or this execution element to begin, we need to be, for example, at least 80% complete in our procurement scope. So having this concept of overlapping engineering, procurement, and construction scope, and having these percentage completes or these rules of thumb associated with them, again, is massively driving our ability to execute in a constraint-free environment. So here what we're really doing is we are supporting the overarching path of construction goal by defining timely engineering and timely procurement scope, and again, applying these rules of thumb to ensure there is no potential breach. And the example graphic here shows our construction scope at the bottom of the diagram, bottom right. That green highlighter encompassing the half dozen or so execution activities. What that's showing is that the preceding procurement and preceding engineering scope is in alignment such that there is no breach of the path of construction in the execution phase there. So once we've completed our front-end planning, we then get into actual field execution. Now, field execution and certainly AWP support of field execution is actually the topic of our next webinar. So I'm not going to spend too much time on this other than really just allude to the fact that once we've defined our front-end planning elements, we then turn to creating daily plans and, more importantly, having a feedback loop from those daily plans or those short interval planning steps. And as the work is actually executed, have that status feed back into the bigger picture CapEx schedule. That gives us the ability then to update our schedule and effectively reforecast during execution. So this is a highly effective way of not just executing the project scope or the project execution, but actually updating the plan as that execution happens. What we've just walked through is really the core steps, the workflow of AWP. Again, I think a very interesting and hugely useful extension to AWP is to add to the mix the ability to risk adjust that cost forecast and that schedule. Now, on the screen here, we have an example where we have our very, very high level path of construction. We've got our onshore and our offshore scope. So we have our onshore construction or execution, which leads into commissioning. Likewise, we have our offshore hookup campaign. And what's interesting is that offshore hookup campaign actually feeds into an offshore startup sequence. That offshore startup sequence has to be completed alongside the onshore commissioning in order for the onshore startup to happen. So there's really two parallel scopes of work. The onshore scope, the offshore scope, both of those are needed before we can actually do the onshore startup. Now, in the the non-risk adjusted scenario, the onshore scope of work actually has a degree of float. In fact, it actually has just over a month's worth of float. The reason being that offshore hookup has that offshore startup campaign. Now, I think what's fascinating here is when we then took into account the risk, the uncertainties, the potential quantity growths on both of those parallel paths, what we thought was the path carrying the float with a month's worth of float or wiggle, the onshore scope, that onshore scope actually became critical. In fact, there was more than 50% chance that the onshore scope was going to be driving the entire project through to that onshore startup. So for me, the marriage of AWP and working from right to left and focusing so heavily on constraint-free execution and the supporting elements from an engineering and a procurement perspective, and then adding to the mix the insight that a risk analysis can bring to the table, I think is absolutely huge. So I believe as we go forward, and again, I think AWP is certainly an emerging technique. I think we have a long way to go, and I think one of the massive opportunities is for us to take the science of risk analysis and include it as part and parcel of the AWP process. So additional innovation areas that we are looking at and certainly implementing within the InEight AWP solution, the concept of having a path of construction builder. And again, I alluded to this in a prior slide, but rather than starting with a blank sheet of paper and trying to forecast those high-level path of construction elements, perhaps I'm a more junior planner that doesn't necessarily have the benefit of those prior projects to leverage from. Being able to use artificial intelligence where the AI engine can mine those historic and prior projects and look at those as-builts and come back with benchmarked and validated path of construction elements that we can then apply to our project, I think is hugely valuable. So, the computer then starts to become context aware as we are defining and setting in stone our path of construction. And again, then from a supporting element perspective, building out our more detailed work packages, whether it's the construction work packages or the supporting engineering and procurement work packages, being able to pull in those subnets from our planning library, from our knowledge library, being able to look at historical risks that occurred on analogous scopes of work. We talked about this concept of rules of thumb. I think this is it's a huge benefit from a planning perspective. It's one thing to get the durations and the costs right, but if the overlap as a result of sequence is wrong, then your plan is effectively it's effectively useless. So the combination of accurate duration, accurate cost, and then realistic and accurate sequence is a very, very big deal. So, this concept of building these work package templates and being guided by the computer, and then of course, adding on top of that the overlay of the ability to do a risk analysis is absolutely a big step forward in AWP. And then third and finally, from a field execution perspective, being able to have those daily plans be automatically generated from our installation work packages. And not only that, but because we're so closely aligned between schedule and cost estimate and the visualization through a 3D model or a 2D drawing, being able to enrich those daily activities with engineering drawings and risk registers and required man hours, so on and so forth. Being able to have a single source of truth on a daily basis, I believe is going to massively improve the productivity out in the field. So really, as we move to conclusion, just a couple of concepts maybe to think about. The acronym AWP, take it very literally. Advanced work packaging. I think it is an advanced way to plan, but we're still using traditional cost estimating and modeling and CPM planning techniques. We are simply pushing the boundaries as to how we use those technologies and, more importantly, bring those technologies together. Work. I think the focus being on work is very, very important. We're planning from an execution perspective. We're not planning from a planning perspective. And while that sounds a little strange, I think it's very, very important. We're focusing all of our planning efforts on enabling on-time execution of the work. And in turn, we're then looking at what do we need to support from an early stage engineering and a mid-stage procurement perspective. And then thirdly, packaging or packages. What we're doing here is we're starting with project scope. We're breaking that out through those 5 levels. And what we're doing is we're constantly packaging the work into manageable components. So I think, advanced work packaging, there's a reason why AWP is called AWP. Traditional project management, theory and textbooks they've all talked about, first of all, project management, you plan the work and then work the plan. It's a very sequential way of thinking about project management. I think we got it wrong. I think instead with AWP, what we're now doing is we're better planning the plan so as to better work the work. This concept of pre-plan, plan, execute, close out, it's a highly sequential way of thinking about building a project. Let's not do that. Let's focus on coming up with a more realistic plan, and let's constantly replan, and let's plan during execution, and everything then drives this concept of on time and delay-free or constraint-free construction and execution. So, I think we've focused a lot on the theory behind AWP. Ultimately, AWP is only useful if it becomes a reality, and at InEight, it is very much a reality. We are adopting a 6-pronged approach to advanced work packaging. Firstly, we are massively investing in the concept of AI, or artificial intelligence, and machine learning. So we're adopting this concept of knowledge-driven planning, having the computer guide and augment the AWP process. I think the fact that we have recognized the huge value within the AWP framework of marrying up front-end planning with field execution and having those two aligned, I think is a huge deal. As AWP becomes more prevalent, you're probably going to hear more about this concept of a digital thread. So think of a digital thread as really the continuing enrichment of project information. Again, whether it's cost, schedule, drawings, risks, so on and so forth, components, all of that information. And really the concept of a digital thread is that if we start with that level 1 and go all the way through to level 5, as we go through each of those levels, we are constantly adding to and enriching our information or our knowledge. That becomes a digital thread. It's a digital asset that is part of the project completion and handover. It's part of the physical asset itself, which in turn actually helps post CapEx project during the operational phase as well. Visualization is a big deal. So the ability to not just render a 3D model or a 2D drawing, but actually use that 3D model and drawing to light up and interactively highlight things like those constraints or the flow of work or the path of construction or the installation work packages or the components. I think what we're doing here is we're dealing with huge volumes of data with AWP. And so from a visualization perspective, looking at those volumes in tabular format is not very useful. Being able to visualize the project, though, in a 3D environment and then hang those digital thread attributes off that 3D visualization is hugely insightful. Deliverable-based planning. So again, I think traditional project management has focused too much on defining the work in isolation, almost to the point of being divorced from the scope of work and what it is we're building. I think with AWP, again, we're looking at the project very differently. We start with the deliverables, and then we look at, well, what is needed to support the execution of the work in order to deliver those deliverables. So this concept of deliverable-based planning. And then finally, collaboration and coordination. I think as an industry in the last certainly 25 years, project management has really evolved through the bringing together of multiple point solutions, whether those point solutions are scheduling tools, cost estimating tools, visualization tools. And I think we've realized that trying to glue together multiple point solutions is not a sustainable means of building a project management solution, and certainly not an AWP solution. What we're doing at InEight is taking a very different approach. We have developed an all-encompassing platform within which we have the capabilities of doing planning, estimating, risk analysis, modeling, field execution. So because we have that single one-stop shop platform, the ability to easily, albeit in a controlled manner, collaborate and coordinate and pass information through to generate that digital thread is really a unique capability, and one that I'm very, very excited about. So with that, I'd like to wrap up today's webinar. Again, the objective here was to give you an introduction into the science of advanced work packaging, and specifically really just highlight the value of starting off by defining this entity known as a path of construction, and then in an iterative manner detail out our plan from the very early planning phase, but more importantly, continue to plan during execution all the way down to that level 5. So the next webinar will actually take the concepts of the field execution planning within AWP and detail those out, and I'll share with you some of the very exciting concepts that we're working on with regards to daily plans, short interval planning, and the enrichment of those plans with the likes of components. So with that, thank you very much.
Thank you, Dan. Again, if you have any questions, please email them to webcasts@innate.com. To learn more about InEight, as well as our planning, scheduling, and risk solutions, visit innate.com and click on the Request a Demo button. And if you'd like to see a schedule of upcoming webcasts, visit innate.com/webcasts. Thank you for watching. This concludes our presentation.